Okay, let's solve problems. We're going to solve two problems for standard candles so that we better solidify our understanding of this. So the first one is a defined problem. State what is meant by the luminosity of a star. We talked about this. This is not the first time we're discussing this. Luminosity of a star is basically the total power radiated by a star. So essentially, 2 marks for total power, the other mark for radiation that is radiated. Okay, explain how a standard candle in a distant galaxy can be used to determine the distance of the galaxy from an observer. And you want to figure out the distance. So you know that a standard candle has known luminosity. So we start from there, because you want to understand what a standard candle actually is. So a standard candle has known luminosity. That's where we start always. Okay, but why is it important? If it has known luminosity, I know that now the radiant flask intensity, okay, the radiant flask intensity can be measured by the observer. Okay, so if you're writing notes, you need this down in your notes. How can you actually measure distance using standard candle concepts? Okay, so then you apply the formula. Okay, F is equal to L over 4 pi d squared, where the distance itself that you want, where d would be equal to L over F 4 pi, the square root of that. That's essentially how you're therefore going to calculate the distance. So you know what a standard candle is. You know that it is known luminosity. You know the total power emitted by that standard candle. Radiant flask intensity, you can measure that. And then you can apply the formula. F is equal to L over 4 pi d squared to be able to calculate the distance itself. Okay. 10 February March 2024, question paper 4.2. A student observes 2 different stars from the Earth. So you have the Earth at the center, star A and star B. Give 2 reasons why some stars appear brighter than others. Guys, this is a bit of a common logic here. It's not really a question that's requiring you to know a particular concept. But why would one star appear brighter than the other? Just think about it. Why would you, if you go in a room or if you're standing outside, you see one torch brighter than the other? Number one is either it's brighter, right? One star has a greater luminosity. One star has a greater luminosity. It's just emitting too much power. Luminosity, sorry for that, than the other. Okay, that's the first reason, right? If one star is giving out too much energy as compared to the other star, then it's going to be appearing brighter. The other reason is one star is closer. One star is closer to the Earth than the other star. So essentially, if you have someone who's close to you, right in your face, and someone who's further away, which torch do you expect to be brighter? The torch that's closer to you as compared to the torch that's further away from you. Ask yourself, well, how can one star appear brighter than the other? What's causing that, right? And these are the 2 different points of view you can tackle this from. Then the last one is a defined problem. This you should know. You should know how to define what a standard candle actually is. And we've talked about this. We've defined it. It's basically an astronomical object with known luminosity. That is essentially what a standard candle is. If you have an object and you know its luminosity, it's a standard candle. So these are typical examination style questions that you're going to encounter underneath this objective. And in the next video, we're going to look at Wind's displacement law to better understand what are some of the areas that you need to cover in astronomy and cosmology. So I'll see you guys in that video.